Hello friends, welcome back to my YouTube channel Journey with Vijay Kumar Srivastav. Today our study topic is weather elements. We will study about various elements like solar radiation, temperature, air, wind, precipitation, rainfall, humidity, atmospheric pressure, ocean currents, cloudiness and visibility. So let's proceed to get the details. First element is solar radiation. Solar radiation is the energy radiated from the sun in the form of electromagnetic waves, including visible and ultraviolet light and infrared radiation. It is also known as shortwave radiation. Solar radiation is probably the most important element of climate and potentially indicate the amount of heat an area is receiving. Now we will discuss about the distribution of solar radiation. From solar radiation, there is direct radiation reaching to the earth by 33%, out of which 3% is getting reflected. And before reaching to the ground, it is absorbed in the atmosphere by 22% and getting reflected by 25%. There are some radiation which is getting scattered, which is coming to the ground by 10% and going upside by 7%. Solar radiation means sunlight is the form of kinetic energy known as quanta or photons, which is traveling in waves form. Solar radiation hits the earth's surface and determines the temperature of the air above. Solar radiation drives evaporation so long as there is water available, and heating of the air affects cloud development and precipitation. Unequal heating of the earth's surface creates pressure gradients that result in wind, and every location on earth receives sunlight at least part of the year. All plants need sunlight for photosynthesis, and pyranometer instrument is used to measure the total incoming radiation. The amount of solar radiation depends on many factors like geographic locations, time of day, season, local landscapes and local weather conditions. So if we see in case of tropical regions, temperate regions, it will vary, not similar. And there are different forms of solar radiations like visible light, radio waves, heat which is in the form of infrared rays, X-rays and ultraviolet rays. As the measurements of solar radiation is concerned, it is higher on clear sunny days and usually low on cloudy days. When the sun is down or heavy clouds are blocking the sun, solar radiation is measured at 0. And solar radiation is expressed in the form of watts per square meter, and solar radiation is the instantaneous intensity. The intensity of solar radiation is recorded by using the instruments solarimeter and heliometer, and the duration of sunshine is calculated by using the simple sunshine recorder, and there is also Campbell-Stokes recorder which is also known as a Stokes sphere, which measure the solar radiation and also known as sunshine recorder. Second element is temperature. Temperature refers to the degree of hotness or coldness of a place or substance. Temperature measures the intensity of heat energy, and when the sun heats up the ground during the day, the air in contact with it gets warmed up. Commonly expressed and measured in degrees Celsius or centigrade or degree Fahrenheit or Kelvin scales. The temperature of a place is largely determined by its distance from the equator, known as latitude, and altitudes also, and proximity to large water bodies and mountains. At temperature below the freezing point of water, changed form of water from liquid to solid, which is the clear indication of temperature effect. Temperature varies because of the heat exchange and it has the mode of conduction, convection and radiation. Thus, to achieve thermal comfort, heat exchange is targeted. Temperature is represented in Kelvin, Fahrenheit and centigrade, for which there are correlating factors and formulas as mentioned here. Temperature is very important factor in determining the weather, and it influences or control other elements of the weather like precipitation, humidity, clouds and atmospheric pressure. Temperature is measured by thermometer, maximum and minimum thermometer and thermograph. Third element is air, which is the mixture of gases in the atmosphere, and about 75% of this air is found in the tropospheres. The oxygen and carbon dioxide in the air is important to the physiology of plants, and oxygen is essential in respiration for the production of energy that is utilized in various growth and development processes. And carbon dioxide is a raw material in photosynthesis. If we will see the contribution of atmospheric gases, nitrogen is contributing about 78%, oxygen 21%, carbon dioxide 0.03%, argon 0.93% and other gases contributing about 0.2%. Next element is wind. Wind is air in motion. If we will see the definition, the horizontal movement of the atmosphere is called wind. Wind is felt when it is in motion and result of the horizontal differences in the air pressure, and movement of air from high pressure to low pressure is generally found, and a speed of the wind depend on difference between high and low pressure. The greater the difference, the faster the wind speed resulted. Closer the isobars, stronger the wind locations. The wind brings with it the temperature of the area it is coming from. Therefore, a high pressure in a warm region will make the temperature in the low pressure area higher. Wind chill is the effect of the wind making it feel colder. As the wind speed increases, air is moving more quickly and therefore removes warm air, and therefore making it seem colder than the actual temperature. Anemometer is used to measure wind speed and direction, and wind is only for wind direction. Air movement or wind is due to the existence of pressure gradient caused by difference in heating. Wind is measured on two scales, on a global scale and on the local scale. On global scale, it is done as a stream flow, jet stream flow, and movement of large air in masses. In case of local scale, only a smaller quantity of air moves. Surface winds are lower and less turbulent at night. Air close to the ground cools, it contracts and the pressure rises. While in case of warm conditions, wind expands and loses pressure. Where both cold and warm air occurs in proximity, the cold flow to the direction of the warm air, and from high to low pressure area to correct the pressure imbalance. Theoretically, cold dense air from the polar regions should blow towards the equator and fill the void where heat warms up the air and causes air molecules to rise and spread out. However, the spinning of earth exerts a force on these currents of air, making them deflect to the left in the northern hemisphere and to the right in the southern hemisphere, which is called the Coriolis effect. Other local factors affect wind speed and direction, such as the uneven heating of the earth's surface and the pressure of mountains. Fifth weather element is precipitation, which is the collective form of moisture that falls from the air to the ground, and it includes rainfall, snow, hail, sleet, drizzle, fog and mist. And water from that falls to the earth from overhead caused cloud formations. Precipitation is a long term and it is predictable factor, and rainfall is the most common form of precipitation. Precipitation is measured by rain gauge and is expressed in millimeter per a time unit like millimeter per day or inches per day. Sixth weather element is rainfall, which can be defined as the quantity of water that is precipitated in liquid form in a specified area and time, usually expressed in millimeter or inches, and rainfall is the most common form of precipitation. It is the falling of water in droplets on the surface of the earth from clouds, and the amount and regularity of rainfall vary with location and climate types and affect the dominance of certain types of vegetation, crop growth and yield, and it is measured by rain gauge, which is also known as pluviometer. Now we will study about next element, humidity. Humidity is the measurable amount of moisture in the air of the lower atmosphere, and it can be also defined as water is present in the atmosphere in the form of invisible water vapor, normally known as humidity. Atmospheric moisture is the most important element of the atmosphere, which modifies the air temperature, and the humidity element of weather makes the day feel hotter and can be used to predict coming storms. The humidity element of climate is the prolonged moisture level of an area that can affect entire ecosystems. The more water vapor in the air, there will be higher the humidity. If the humidity level exceeds the amount that air can hold, then condensation will take place, forming dews if it is warm, and it will be in frost if it is cold. At higher altitudes, clouds begin to form, and humidity also varies with temperature. Warm air can hold more moisture than cold air. There are different types of humidity like absolute humidity, relative humidity and specific humidity, about which we will discuss in next slide. Relative humidity is the amount of moisture present against the total moisture the air can hold at that temperature, and it is expressed in terms of percentage. Relative humidity is ratio between the amount of moisture present in the air to the saturation capacity of air at a particular temperature, and 100% relative humidity means entire space is filled with water and there is no soil evaporation and plant transpiration, and relative humidity influences the water requirement of crops. The relative humidity affects the opening and closing of the stomata in plants, and stomata regulates loss of water from the plant through transpiration and photosynthesis. Relative humidity is more useful expression for designers as it gives the direct potential of evaporation. Relative humidity refers to the amount of water in atmosphere. If there is 0% relative humidity, means there is only air and no water. In case of 50% relative humidity, there will be 50% of water and 50% of air. While in case of 75% relative humidity, there will be 75% of water and 25% of air. While in case of 100% relative humidity, there will be filling of water and no air at all. Relative humidity of 40 to 60% is suitable for most of the crop plants. Very few crops can perform well when relative humidity is 80% and above, and when relative humidity is high, there is chance for the outbreak of pest and diseases. And relative humidity is measured by hygrometer or sling psychrometer. Second type of humidity is absolute humidity. It is the amount of moisture actually present in unit mass or unit volume of air expressed in gram per kilogram or gram per cubic meter. In other way also, it can be defined like the total amount of water vapor present in per volume of air at a definite temperature. Third type of humidity is specific humidity, which is defined as the mass of water vapor in grams contained in a kilogram of air, and it represents the actual quantity of moisture present in a definite air. A specific humidity is the ratio of water vapor mass to total moist air partial mass. Next weather element is atmospheric pressure, which is defined as the force per unit area exerted against a surface by the weight of air above that surface. Atmospheric pressure is the weight of atmosphere or air on the surface of the earth, and air has a specific weight, and earth's atmosphere pressure systems have a direct impact on the precipitation. The places dominated by low pressure tends to be moist, while those dominated by high pressure are dry. The seasonality of precipitation is affected by the seasonal movement of global and regional pressure systems, closely related to wind, since wind is air moving from high to lower pressure. The greater the difference in pressure, the faster will be wind. Low pressure occurs when the sun heats up the land surface, which warms the air in contact, and high pressure systems come out when usually cooler dense air sinks. Atmospheric pressure is represented by isobars on weather map and measured in millibars by barometer. At high altitude there will be lower air pressure, while at sea level there will be higher air pressure. Ninth weather element is ocean currents, which greatly affects the temperature and precipitation of a climate. Those climates bordering cold currents tends to be drier, as the cold ocean water helps stabilize the air and inhibit cloud formation and precipitation. Air traveling over cold ocean currents lose energy to the water and thus moderate the temperature of nearby coastal locations. Air masses traveling over warm ocean currents promote instability and precipitation. Additionally, the warm ocean water keeps air temperature somewhat warmer than location just inland from the coast during the winter. 10th weather element is cloudiness. A cloud can be defined as hydrometer consisting of minute particles of liquid water or ice, or of both, suspended in the free air and usually not touching the ground. It may also include larger particles of liquid water or ice, as well as non-aqueous or solid particles such as those present in fumes, smokes or dust. Clouds are the most obvious feature of the sky and gives a clue about atmosphere and anticipate changes. Each type of cloud forms in a different way and each brings its own kind of weather. Clouds play multiple critical roles in the climate system and efficiently reflects light to a space and thus contribute to the cooling of the planet, and clouds are the base for precipitation. In summer, cloudy days provide protection from the rays of the sun, and in winter, cloudy skies at night diminish nocturnal radiation and check the fall of temperature. Clear, calm weather nights are usually the coldest and helps in condensation. Cloud cover has an appropriate role in weather description and forecasting. A cloudiness or overcast sky is usually a clear indication of weather conditions, and cloud cover is measured in octaves, and cloud types can also signal potentially fair or bad weather, and cloud fall in three basic categories like high, medium and low level clouds, and the instruments for measuring clouds height is called ceilometer. Here we will study the cloud development. Clouds forms when the invisible water vapor in the air condenses into visible water droplets or ice crystals. For this to happen, the parcel of air must be saturated, like unable to hold all the water it contains in vapor form, so it starts to condense into a liquid or solid forms. Most clouds are formed by surface heating and free convection, lifting of air over topography, and widespread air lifting due to surface convergence and lifting along weather fronts. Clouds form as air rises and expands and cools. Next weather element is visibility, which is the most critical weather element, and there are obstructions to visibility which includes clouds, fog, smoke, haze and precipitation. Visibility is represented by meteorological optical range MOR and varies with the background illumination. And in extremely clean air in Arctic or mountainous areas, the visibility can be up to 70 kilometers and it can reach up to 100 kilometers. Visibility is often reduced somewhat by air pollution and high humidity. Fog and smoke can reduce visibility to near zero, making driving extremely dangerous. The same can happen in a sandstorms in and near desert areas or with forest fires. Heavy rains, such as to form a thunderstorm, not only causes low visibility but the inability to brake quickly due to hydroplaning. Blizzards and ground blizzards blowing snow are also defined in part by low visibility. So this is all about weather elements. Thank you very much and see you again shortly.